So students, chemical properties of nonmetals will depend upon the electronic configuration. And electronic configuration we have discussed in the last class. That is the arrangement of electrons inside an atom. If you see the arrangement of electrons in these three elements which are shown here, nitrogen, oxygen and chlorine. So the electronic configuration is like that, 2, 5, then it is 2, 6, and then it is 2, 8, 7. So according to the Lewis rule, every element combines with another element for formation of compound because it wants to complete its octet. And what do you mean by octet? What is actually octet? Octet means 8. Okay, so there should be 8 electrons in the outermost shell of an element. So see here, this is the outermost shell. This is the outermost shell of nitrogen. This is the outermost shell of oxygen, and this is the outermost shell of chlorine. So here these elements react with other elements to complete their octet. So if nitrogen is having 5 electrons in outermost shell, how many more electrons are required here? How many more electrons are required to complete the octet? Yes, students, how many more electrons are required? Yes, Ajaz, very good. First element, that is nitrogen, requires 3 electrons to complete its octet because it is already 5. Okay, already 5 electrons are there. So if 3 electrons are more added, so it will become 8, that the octet will be completed. In the similar way, oxygen O is having 6 electrons in the outermost shell, and if it is getting 2 electrons from any species, so it will get completed like 8. And then again talking about chlorine. So for chlorine, this is the outermost shell which is having 7 electrons. Outermost shell is having 7 electrons. So 7 means how many electrons are required now? Only 1 electron is required, and so its octet will be completed. So depending upon the electronic configuration and number of electrons in the outermost shell, the elements react in that manner. Now, formation of ions. Non-metals have a tendency to accept electrons in their valence shell to form negatively charged ions called anions. So, when we have discussed about metals, so we have discussed that they form cations. Okay, metals have the tendency to form cations. Cations means positively charged species. Cations means positively charged species. And when we talk about non-metals, non-metals have the tendency to form anions. Non-metals have the tendency to form anions. Anions means negatively charged species. Cations are positively charged species and anions are negatively charged species. So look at look at these reactions. So the three reactions are shown here. First one is of chlorine, second is of oxygen, and third is of nitrogen. So since there are 7 electrons in the outermost shell of chlorine, only 1 electron is required to complete the octet. Only 1 electron is required to complete the octet. That's why 1 electron is being accepted here, and there is 1 negative charge. Okay, negative charge on a particular element depends upon how many electrons are accepted. If only 1 electron is accepted, then 1 negative charge will come. Okay, since only 1 electron is accepted, only 1 negative charge is there on the chlorine atom. And then see, second is oxygen. So if you see the electronic configuration, there are 6 electrons. There are 6 electrons in the outermost shell of oxygen. So how many required? 2 electrons are required to complete the octet. So this oxygen is going to accept 2 electrons, and that's why here you have 2 minus charge. You have 2 minus charge. Okay, in the similar way, nitrogen is having 5 electrons in the outermost shell, so it will require 3 electrons to complete its octet, and that's why here 3 minus charge has been shown on the ion, and it is known as nitride ion. Okay, this is nitride ion, this is oxide ion, and the first one is the chloride ion. Now first is the reaction with oxygen. So here we are going to discuss some of the non-metals and the reaction with oxygen. So non-metals have tendency to combine with oxygen very easily. Non-metals very easily combine with oxygen, and what has been formed here is oxides. Okay, oxides are formed. So if you see the reaction is quite simple here. Carbon plus oxygen, you are getting carbon dioxide. Again, this carbon dioxide when reacted with sodium hydroxide, we are getting sodium carbonate plus water. Sodium carbonate plus water. Okay, now this why this is reacting with sodium hydroxide. So we are talking about non-metals. Okay, we are talking about non-metals. So the oxides of non-metals are acidic in nature. Oxides of non-metals are acidic in nature. Oxides of non-metals are acidic in nature, and so since they are acidic in nature, so they are going to react with the base. We know that the sodium hydroxide is a base. This is a base. This is an acid. So there is an acid-base reaction, and the product which is formed it is salt plus water. Okay, whenever acid-base reaction takes place, water and salt is formed. Okay. So remember this thing: acids and bases react with each other to form salt and water. The same condition is happening here. This oxide is acidic, and we are using a base, so acid-base reaction is taking place, which is known as neutralization reaction. Now these are the oxides of non-metals. Carbon dioxide is there, sulfur dioxide is there, sulfur trioxide is there. Okay, these three are the oxides of non-metals. So when they are reacting with water, when these oxides are reacting with water, you can see here you are getting acid. Carbon dioxide reacting with water, it is giving you carbonic acid. Sulfur dioxide reacting with water, it is giving you sulfurous acid. And sulfur trioxide reacting with water, it is giving you sulfuric acid. So whenever an acidic oxide reacts with water, it will give you acid. Okay, always this reaction takes place whenever acidic oxide reacts with water, it is giving you acid. Any doubt is there? Students, are you listening me?
Yes, miss.
Sir,
Yes, miss.
reply fast. Next is reaction of nonmetals with dilute acid. So as it is written here, non-metals do not react with dilute acid, so we don't need to study this reaction.
मिस आपकी आवाज एकदम स्लो आ रही है.
What happened? Any doubt is there? Write your doubt and send it to me. Next part is the noble metals. What do you understand by noble? What do you understand by noble? Noble means such metals do not react with other elements easily. Such metals do not react with other elements easily. So what are the metals which are given here? Metals like gold, silver, platinum, palladium and rhodium. These are said to be noble metals because they do not react with other elements. They occur in nature in the elemental state. Means when we talk about other metals, their occurrence. So other metals are not obtained in the pure state. They are always obtained in the combined state. If you talk about iron, okay, iron is obtained from the earth's crust. Okay, iron is obtained in the earth crust. So you will not get pure iron from the earth's crust. You will get iron in the form of oxides. Iron oxide you will get in the form of sulfides. You will get in the form of sulfates. Okay, like this they are obtained. They are not obtained in the pure form. But when we talk about these noble metals, so these noble metals are obtained in elemental form, means they do not react with other elements. So gold which is 100% pure is called 24 karat gold. Okay, 100% pure gold is known as what? 24 karat gold, and it is actually very soft. So it is so soft that we cannot make ornaments. Since the 24 karat gold is very soft, it cannot be used to make ornaments because such a soft gold, when it is bended, it will break very easily. So what is done here? Along with the gold, some other metals are mixed. Okay, along with gold, some other metals are mixed. And which metals are mixed? Copper and silver. Okay, some amount of copper and silver are mixed along with the gold so that softness is reduced. Okay, excessive softness is reduced and ornaments can be used in a good way. So they will not going to bend, they will not going to break easily. So basically, we do not use 24 karat gold for making ornaments. The gold which is used is 22 karat, means some of the impurities means other metals like copper and silver are mixed in the gold. Next is uses of noble metals. first is gold, silver, and platinum. As we know, these are very much used in making ornaments. Then second is silver. Silver is also used in medicines, and also silver is used in making. Silver is used in foodstuffs. Also, you might have seen that some sweets have a silver foil or gold foil on it, right? Have you seen foodstuffs having silver foil and gold foils? Especially sweets when we talk about sweets. So this silver is basically used in medicines, and it is also having antibacterial property. Antibacterial means it has a property to fight against the bacteria. Then gold and silver, as we know, they are used to make medals. Also, they are used in electronic devices, but to a very smaller extent, because we know that these gold and silver are quite costly. So we cannot use a large quantity of gold and silver in electronic devices. So very, very small quantity is being used in very rare cases, not always. Then platinum, palladium metals are used as catalyst. So catalyst means they are used in the chemical reactions. They are used in the chemical reactions to speed up the chemical reactions. What is the work of the catalyst? Catalyst is a chemical substance or any species which helps to increase the speed of the reaction. So these metals are used as catalyst. Next is again purity of gold. So as we have discussed above, the same thing is given here also, purity of gold. That we know gold is a noble metal. It occurs in nature in the elemental form, means it is not associated with any other element. And so it is, since 100% pure gold is very soft, so that much soft metal cannot be used for making ornaments. So some other metals have been added, and which metals are added? This copper and silver is added in the gold to make it less soft, so that ornaments can be used effectively. So here some description is given that 24%, 24 karat gold. It means there is 100% gold in it without any impurity. Then talking about 22 karat gold, it means there is 91.66% of gold, and rest other is the impurity. Impurity in the sense other metals are added like copper, silver. Then here is a complete list of what type of gold is available. So 24, 22, 18, 14, 12, and 10, and most commonly used is 22. Okay, most commonly is 22 karat gold is used, which is containing 91.66% gold. And depending upon the carat, the rate of the gold also changes, because gold is a costly metal, and if the amount of gold is increasing in the ornaments or in the objects in which we are going to buy, so if the more amount of gold is present, so price will also differ. This different carat gold will be having different prices. Now next is corrosion. Corrosion is basically the destruction of the surface. Corrosion is what? Corrosion is basically the destruction of the metal surface. So metals are kept directly in the open air, right? We don't keep always in the safe place or locked where somewhere. So they are usually kept in the open air, and the gases which are present in the air can react easily with the metal compounds. Okay, and because of this, the reaction starts because there are so many gases present in the air and also the moisture content which is present in the air. So these air and moisture reacts with the metal surface and different chemical compounds are formed, and because of this the metallic surface gets affected. Suppose this is any piece of metal and air is present outside it, moisture is present outside it. So what will happen, the piece of the metal will react, upper surface will react with the moisture and gases present in the air, and it will get corroded. It will get corroded. This is known as corrosion. Means there will be a change in the surface of the metal. So the shine of the metal will be lost. Initially the metal surface was very shiny, but when it is reacting with these gases and moisture present in the atmosphere, some other compound will be formed. After formation of such compound, what will happen? The shine will be lost. And such type of reactions, this is known as corrosion. This is known as corrosion, and most of the metallic objects which are placed openly in the air, they undergo corrosion because metals are quite reactive. They are quite reactive. They easily react with whatever they come in contact, except noble metals. Okay, noble metals have the property that they do not easily undergo reaction, but except noble gases, except noble metals, other metals have very high reactivity and they react very easily. Do you have any doubt here? Other students which have connected, are you listening? Yadav, Zikra, Farzeen, on. Okay, there is one information given to you. We'll go through this. What was the page number? Okay, got it. So see, there is some information given here. There is a Statue of Liberty in the sea near New York City in America. The original surface of the statues was made up of copper. Okay, so this statue, it was made up of what? It is made up of copper, but now it looks green. This is because green colored copper carbonate has been formed by a reaction of copper with the carbon dioxide and moisture present in the air. Since copper is a metal, we know copper is a metal, right? So, and just now I have said that metals have strong tendency to undergo the reaction with any of the element which comes in contact with it. So this copper reacts with carbon dioxide which is present in the atmosphere, the carbon dioxide and moisture present in the atmosphere. And what happens? See what is written here. When this copper reacts with carbon dioxide and moisture present in the atmosphere, it forms copper carbonate. It forms copper carbonate, and because the color of the copper carbonate is green, color of copper carbonate is green, so the color of the statue is been slowly changing to green because entire copper of the statue is getting reacted. So the original color of the statue is getting changed into the green color, which is because of copper carbonate, which is continuously forming because of the chemical reaction. So this is again an example of corrosion, means how the metal surface is getting destroyed because of gases present in the atmosphere. Now make a list and discuss. So here some examples of corrosion are given, how what is corrosion and how the corrosion is taking place. So talking about iron, so we know rusting is very common. Iron articles get rusted very easily. So how that rust is been formed? That rust is formed when iron reacts with oxygen gas. How rust is formed? Rust is formed when iron reacts with oxygen gas which is present in the atmosphere. Then when copper reacts with carbon dioxide, it forms copper carbonate. Means different metals are undergoing corrosion in different ways. Iron is getting corroded by oxygen gas. Copper is getting corroded by carbon dioxide gas. Silver is getting corroded by hydrogen sulfide gas. Again, this hydrogen sulfide gas is available in the atmosphere. So much destruction is not good. Destruction of metal surfaces is not good so much. So what is been done? We need to protect the metals from getting corroded. And what can be done? You might have seen that the iron articles are coated with paint or grease. Iron articles are coated with paint or grease so that they do not come in contact with the air. So if they don't come in contact with the air, what will happen? They will not undergo the reaction. Suppose this is the iron article. Okay, and what is done is paint is applied on the iron article. Okay, when paint is applied on the iron article, what will happen? It will not directly come in contact with the air. If it is not coming directly in contact with the air, reaction will not take place. No reaction will take place because iron is not in direct contact with the air. In this way, the iron article can be protected from getting corrosion. Okay. So if we make a short list, iron getting corroded by oxygen gas, copper getting corroded by carbon dioxide gas, silver gets corroded by hydrogen sulfide gas is H2S. H2S is known as what? Hydrogen sulfide gas. And what is being done to protect these metals? What is done, say, what can be done to protect these metals? We can coat these metals, we can apply a layer of grease or paint on these metals so that they can be protected from corrosion. Also, one more method is there, that is we can apply a layer of another metal. For example, iron easily gets rusted, so again another coating of zinc is applied on the iron so that corrosion is prevented. Next is what alloy. So alloy, what is actually alloy? It is a homogeneous mixture of two or more metals. What is alloy? It is a homogeneous mixture of two or more metals or homogeneous mixture of metal with non-metals. So just now we have studied about gold which is mixing with copper. Just now we have studied that gold is been mixed with copper to make ornaments. So again when these two metals are mixed together, it is known as alloy. Okay, when two or more metals are mixed together, it is known as alloy. So this is not the only case. There are other alloys also available. For example, the alloy bronze. Bronze alloy. Bronze alloy which is available. It is made up of what? Copper and tin. Then again the stainless steel what we use at our home. It is also an alloy which is made up of iron with carbon. So there are different types of alloys available which are a mixture of metals and non-metals. Again, one information is given here. There is an iron pillar in the premises of Qutub Minar in Delhi, made about 1500 years ago. These pillars is lustrous even after so many years. So, since these pillars are made up of what? Iron, and we know that iron undergoes corrosion very easily because of rust formation. But still, these pillars are quite lustrous. And why? What is the reason here? Because these are been made up of alloys. Okay, because it is not containing only iron, it also contains small proportion of carbon, silicon and phosphorus in it. So when other metals or non-metals are mixed with the metal, what happens? The tendency to corrosion also gets decreases. So alloy is always beneficial because it increases the corrosion fighting tendency. Okay, so with this we have completed our chapter. Do you have any doubt here? Which notes are remaining? Which chapters? Tell me. Notes of which chapters are remaining? Notes of which chapters are remaining? 10 and only 10. 10, 7 and okay, chapter number 10 and chapter number 7 notes will be provided to you. Anything else you want to ask? Okay, ending the lecture then.